Dear students, today we are going to learn another important topic in Laplace transform, that is Laplace transform of periodic function. In this video, we are going to learn the definition of periodic function with the example and Laplace transform of periodic function with the example problems. Let's say the definition of periodic function. A function f of t is said to be periodic if f of t plus p equal to f of t for all t. The least positive value of p is called the period of f of t. In other words, the wave or cycle is getting repeated after certain time interval over the period of time is called a periodic function. Example, sin t and cos t are periodic function with period 2 pi. Look at this diagram. We have a sine wave, and here in this interval 0 to pi we have a positive half cycle. In the interval pi to 2 pi we have a negative half cycle. In the interval 0 to 2 pi we have positive and negative half cycle. Again 2 pi to 3 pi we have a positive half cycle. 3 pi to 4 pi we have a negative half cycle, which means 0 to 2 pi we have a one cycle, and 2 pi to 4 pi the same cycle is repeated, which means the wave is getting repeated after certain time interval over the period of time. Such kind of function we can call it as periodic function. Let us see Laplace transform of periodic function. Let f of t be periodic function with period p, then Laplace transform of f of t is given by Laplace transform of f of t equal to 1 by 1 minus e power minus ps into integral over the limit 0 to p e power minus st into f of t dt. Here p is time period of first function. Time period is nothing but time taken to complete one cycle. And here the integrand is Laplace transform of first cycle of periodic function. We can go for the problems. Find the Laplace transform of f of t in the interval 0 to a, the second function 2a minus t in the interval a to 2a, and f of t plus 2a equal to f of t for all t. And here instead of period p we have a 2a. So f of t plus 2a equal to f of t, which means the given function is periodic function with period 2a. Now we can go for the solution. Laplace transform of f of t equal to 1 by 1 minus e power minus 2as integral over the limit 0 to 2a e power minus st into f of t dt. Here the total interval 0 to 2a is divided into two subintervals. One is 0 to a, another one is a to 2a. We have two different functions. The first function in the interval 0 to a, and the second function in the interval a to 2a. The first function is t, second function is 2a minus t. In the first integrand f of t is t, in the second integrand f of t is 2a minus t. Now the integrand is product of two functions. Whenever we have a product of two functions in the integral, we have to apply integrations by parts or Bernoulli's equations. Now we are using Bernoulli's equations here, which is equal to 1 by 1 minus e power minus 2as into t into e power minus st divided by minus s, which means that we have used it Bernoulli's equation, and this is u in v1 we have integrated, minus differentiate this as 1, integrate again e power minus st by s square in the interval 0 to 2a. Again the second integrand 2a minus t into e power minus st divided by minus s minus, differentiate it, it becomes minus 1. Again we have to integrate this one, e power minus st by s square in the interval a to 2a. Now substitute upper and lower limit values. Replace t by a. Replace t by a, which means minus a e power minus as by s minus e power minus as by s square. Use the lower limit, minus 0 into anything 0. So here minus e power 0 is 1, that is minus 1 by s square, plus substitute upper limit value here, 2a minus 2a is 0, 0 into anything 0. Now we can go for here for the second term, e power minus 2as by s square. This is e power minus 2as by s square minus this for applying lower limit, minus here substitute the lower limit value. Here also we have a minus 2a minus a. 2a minus a is what? A, right? So e power minus as by s plus substitute here e power minus as by s square and simplify it, minus a into e power minus as by s, here minus e power minus as by s square. So minus of minus plus 1 by s square, e power minus 2as by s square. So minus of minus plus a into e power minus as by s. So minus into plus, it becomes minus e power minus as by s square. Okay, so here a into e power minus as by s, which is positive here, minus a into e power minus as by s. We can eliminate these two terms, right? Now we have 1 by 1 minus e power minus 2as into 1 plus e power minus 2as minus 2 times of e power minus as. After simplifying this, we have here, this is of the form a square plus b square minus 2ab. We can write a minus b whole square, right? In denominator, we have 1 square minus e power minus as whole square. These are the form a square minus b square. We can write a minus b into a plus b, right? So in numerator we have a minus b whole square, in denominator we have a minus b into a plus b. So a minus b whole square, here a minus b. So get cancelled. We have one term, 1 minus e power minus as by s square into 1 plus e power minus as. We know that 1 minus e power minus theta divided by 1 plus e power minus theta is tan h theta by 2. Instead of theta, we have minus as. So we can write 1 by s square into tan h as by 2. Problem comes to end now. And this is the Laplace transform of the given function. Now we can go for one more problem. Find the Laplace transform of the rectangular wave given by f of t equal to 1 in the interval 0 to b, the second one minus 1 in the interval b to 2b, and f of 2t plus 2b equal to f of t, which means the given function is periodic function in the interval 0 to 2b with period 2b. Given that f of t equal to 1 and minus 1 in the interval 0 to b and b to 2b. Now we have a splitted interval. Now we can apply the Laplace transform of the periodic function. Can be written as 1 by 1 minus e power minus 2bs integral over the limit 0 to 2b e power minus st into f of t. The given function is divided into two different functions. First function is 1, the second function is minus 1. Now replace 1 here, minus 1 for the second integrand. So 1 by 1 minus e power minus 2bs into integral over the limit 0 to b e power minus st into dt plus integral b to 2b e power minus st into minus 1 dt. So integrate it directly. So e power minus st by minus s over the interval 0 to b minus e power minus st divided by minus s over the interval b to 2b. Substitute upper and lower limit values. 1 by s into 1 minus e power minus 2bs into minus e power minus bs minus 1 plus e power minus 2bs minus e power minus bs, which is equal to 1 by s into 1 minus e power minus 2bs minus e power minus bs. Here also we have a minus e power minus bs. This is of the form a square plus b square minus 2ab. So we can write a minus b whole square. In denominator we have 1 by s into a minus b into a plus b, and this is a square minus b square. 1 minus, that is 1 square minus e power minus bs whole square we can write. So a square minus b square can be written as a minus b into a plus b. So a minus b whole square, here a minus b. So one term can eliminate it. Now we have 1 by s into 1 minus e power minus bs divided by 1 plus e power minus bs. I told you already 1 minus e power minus theta divided by 1 plus e power minus theta is what? Tan h theta by 2. Here theta is minus bs. So 1 by s into tan h of bs by 2. Okay, so problems comes to end now. So problems for practice, work it out yourself. Find the Laplace transform of the rectangular wave function sin omega t over the interval 0 to pi by omega. Second problem, find the Laplace transform of the square wave function defined by f of t. So e and minus e, this is a constant function. Okay, thank you for watching this video.